Okay, so I'm going to start off the discussion today. Tomorrow the lab is due to get, I know you guys, you can't redo labs, okay? So it's like when you get a grade on a lab, you get disappointed because you get like a lower grade than you would like. But when you look at it, you realize you didn't maybe include units where there were some units. Every number should have a unit, okay? And every calculation should have a setup with an answer with units, okay? If you have to write out equations, you write them out properly and balance them and all that good stuff. All plays into your final grade, plus your results, how close you are. And I don't think anybody's in here is going to be more than 10% error. Okay, just based upon the volumes that I see and those type of things. So for a question on your lab, if you get a number that's way off of 22.4, you need to go back and look at what you're doing to calculate it. Because one of your values is off. Something's off. Okay, and if you need to ask a question of me, it'd be better to ask a question of me before you hand it in than to hand in something that's way off because you got a wrong calculation somewhere. Okay, so I can give you a hint. I said, well, you might look at question number 3. I think that value doesn't look right, something like that. And I can help you with that, but if you don't, then I'm not going to be able to. Now, tomorrow, I think most of you will be here. It sounds like because you don't take off for track until later. And that'll be good because we'll go through the second part of what your assignment's based upon. Your assignment you're going to get today will be due on Friday. Okay? If you're planning way ahead, okay, I know track meets are on Thursday, but next Thursday we'll have a test. And if you can get in before that to take it, that would probably be better. I mean, you could take it Friday probably in class because we'll go over it in class. The trouble with taking it Friday, the time that you have to take it's a little bit less because we have a shorter day. Okay, so just be conscious of that. I know there's a lot of things going on toward the end of the year, different things like that. So that's the plan. If you can take it beforehand, I think most of you would be ready. By then, if you took the opportunity to work through the review, and I'll probably get the review out Monday. So you have plenty of time to look at it, go through it. All right, so the last thing, this is pretty much the last thing that we'll do, and it's called the ideal gas law. And it allows me to solve for a volume, pressure, temperature, or moles. So it incorporates everything, pressures and volumes and moles and temperature. And it allows me to figure out a pressure, temperature, volume, or moles at any point in time. I don't have a before and after picture. I have like right now picture of what the pressure is, what the volume is, right now. Okay? And so to kind of understand how it's put together, we're going to use this concept that you guys are trying to solve for. So this is the answer that you guys are coming up with. This is the answer you guys are coming up with in your lab. Did anybody come up with an answer yet for their lab? Are they still working on it? Anybody come up with the answer for number, I think, is it 5 or 6? Anybody come up with the answer for 6 yet? No? You're still working toward that goal? Okay. So this is the answer that you're supposed to come up with because you're converting your volume based upon a new pressure and temperature. And then if that volume and the number of moles that you came up with of hydrogen gas, you should be able to divide them out and you'll get liters per mole. That's going to take place at what we call STP. So we know temperature here is what? 0 degrees Celsius, or we can say 273 Kelvin. Okay? The pressure here is 1 atmosphere. All right. We also can relate that pressure in other units. So can you guys tell me the other units that we have? Units of millimeters of mercury, and we have kPa. That's the ones we're going to look at. So does anybody know the standard pressure in 760? That was in lab. You had to make sure on the part where you converted it to the new pressure P2 that it had to be 760. So on your lab, your pressure was in here at 730 or 720 something, and then you had to create a new scenario where the pressure is 760. And then, you guys remember what kPa is? kPa is 101.3. And the reason why kPa is there is because PA is newtons per meter squared, and it's a way to measure it with looking at force. Okay, so we have those three pressures that P can be, and if we have those conditions met, we get 22.4 liters. If we have 1 mole of a gas under those conditions. Okay. So on this left side, we're going to have you guys tell me what law this is, so we can review this a little bit. So P times V equals a constant. What law is that? Starts with a B. Boyle's. Okay, P over T. Gay-Lussac's. V over T. Charles. And the last one we just learned, which is V over N. Start with an A. Avogadros. So guys, what we're going to do with all of these, we're going to incorporate those into one setup. One setup and how they relate. So, and then we're going to come up with one constant. We're going to call it the ideal gas law constant. So I'm going to take all of these laws and say, and it's not the combined gas law. That's something where we didn't have moles involved with that. That's kind of like before and after picture. And this one has a right now picture we're looking at. So tell me, what do you think K equals? And we're going to change this to a different symbol here in a second. So what does K equal when I combine all these laws? Okay. You tell me what's going to be, what variable is going to be on top? P, yep. V, yep. What's on bottom? T and then what? Yeah, it looks like an H. It's supposed to be an N. N is moles. Okay, now we're not going to show it as K anymore because we need to make sure, like how do you guys represent 3.14 in when you're looking at finding a circumference or volume or anything like that? Pi symbol, right? So we're not going to use K anymore because that's too general. So if we're talking about what's called the ideal gas law constant, what we're going to do is we're going to represent it with what's called an R, capital R. So anytime you see a capital R, that's going to represent what we call the ideal gas law constant. And it allows us to solve lots of problems. So I'll rewrite this on another page. But guess what we just did? We just went ahead and know that if we take those relationships, we will be able to solve for R. So, but what I want you to do, and we're going to have you guys help me out here. What I want you to do is I want you to solve for R in 3 different ways. Okay? We're going to come up with 3 different R values, and I'll explain why here in a second. So this is what I want you to do. The first 2 rows, I need you to solve for R when the pressure is 1 atm. So you guys have the volume, you got the moles, you got the temperature, and then the first 2 rows are going to use 1 as their pressure. So go ahead and calculate the R when pressure is 1 atmosphere. Middle 2 rows, I'm going to have you solve for R if the pressure is in millimeters of mercury. Okay? You're going to plug in the numbers, and then give me an R value. And the last 2 rows, you're going to solve for R using 101.3 kPa as your pressure. So go ahead and do that, and then we'll go ahead and write them down. Remember, N is moles, T is temperature in Kelvin, V is volume, and P is pressure. So in this one, we're going to use that equation, PV equals nRT. Okay, so on this one, this is the volume. This is going to be temperature, but I'm going to cross it out. I'm going to go 284.2 because it's like 0.15. So, and then this is your pressure. What did it be? 294.
Yeah, it's 294.
294. You're right. Okay, and so there's your pressure. So we got PV nRT. What are we solving for? Moles. So what's the pressure? 0.95. What's the volume? 0.890. So our values are again going to be 0.0821 when we have atmospheres, right? And then it's going to be 62.4 if we have millimeters of mercury. And if we have kPa, we're going to use 8.31. So what R do we use? 0.0821. Okay, and then I could put units in there, but I'm not going to because there's 4 units that you'd have to show. So then the temperature is 294.2. Go ahead and solve for that. Go ahead and solve for moles and see what you come up with. Solve for moles. Then we'll do one more problem. So on this one, you have your setup, PV over RT. Pressure is 0.95 atmospheres, volume is 0.89 liters. 0.0821 would be the constant you need to use on this one. And then 294.2 is the Kelvin temperature, so it would be 0.035 moles. Okay, so this next one I'll just have you do. Okay, and then see if you come up with the right answer using the proper method. So in this one, we're going to look at finding the temperature in Celsius. So when you get your final answer, it's always going to be in what unit? If it's temperature. Kelvin. And then you need to subtract to get Celsius, right? So go ahead and see what you can come up with. Okay. So again, we have PV equals nRT. And then you've got your 3 constants. So go ahead and solve for that one. That'll be the last one we'll do. And then we'll give you okay, so then we're solving for temperature. And so T is equal to PV over NR. Or RN, NR, however you want to state it. And then the R value is going to be which one? 62.4 because it's in millimeters of mercury. So I'm going to go ahead and switch pages. I did this in period 1, and I believe this is the right setup. So you take 821 pressure times the volume of 4.04 liters. Divide by 62.4 and 0.127 moles. The answer you come up with is 419 Kelvin, but that's not the answer they wanted in. They wanted in degrees Celsius. So then you subtract 273. Yes, ma'am.
Do you want to see our answer in Kelvin in our work, or can we just subtract
No, I mean, no, as long as I can see your setup and then realize that you probably went ahead and subtracted it right away, so, yeah. All right, so the assignment, not a lot of problems, but enough to kind of get you to where you need to be. It's on page 346. We'll do 55 through 57, 60, 61 CD. Okay? So, the ones that we'll go through tomorrow in class are 60 and 61, C and D. So if you miss, I would imagine the discussion would be similar to today's, where it'll take probably 15 minutes. We get going on it and go through maybe a different way to approach this so that we can do the lab on Monday. Yes, ma'am?
On the test, do you want us to have the R values for like atmosphere, milligrams, and mercury? Do you want those memorized? Or
No, you do not have to memorize them. I give you all the equations. I give you all the R values. That's everything will be supplied to you. You just have to know which one to use and then rearrange it and which to solve for. Okay? There you go. You guys, if you need to work on your lab, you're sure more than welcome to do that. That's due tomorrow. This is due on Friday. So if you need some help or you need some guidance on your lab, you can ask.